This is our lecture note for today. Please confirm you can see my screen.
Yeah, I can see.
Yes, I can see your screen.
All right,
Yes, I can see yours.
just like Hvac Charles just said, this is a continuation of our class we started yesterday, and this is a continuation of it. So I have start to do with the part identifications and their function, and we'll dive into troubleshooting, and then give room for question and answers, and we close the class. This is just a diagram of HVAC system. I will try to mix it up. I will try to balance it up with the residential AC, if not mobile AC, for some of us that might have cars and we are having issues with our AC. So during question and answer session, if you have question, it does not really mean it should be here in the one on industrial, which has to do with our ships. It could be from your residential, it could be from your car. We'll be glad to give you answer. So this is just a line diagram of the HVAC system. Yesterday, we made mention that it is a closed loop system, right? If it become open, means that there is leakage in the system. So this is just a component. So as you progress on the class, you'll be able to see the picture and also function of each component. As you can see from the line diagram, we have compressor there. With the arrow there shows you the directions of the refrigerant flow. And in this system, we have, after your compressor, you can see the oil separator. From oil separator to the condenser, from condenser to filter dryer to expansion valve. And there's a solenoid attached there. Then from there, we have evaporator. Then your sensing bulb and goes back to the compressor and the cycle repeat itself. As simple as that. Before I proceed, I would like to ask a question. Can somebody let me know what is missing in this diagram? Should I call name? Is anybody that want to try? What is missing in this diagram? All right, I will proceed. I think that will be part of your test question. So that takes us to the next slide.
Okay, good. Good evening, sir. I would just want to try that. Although today is the first time I'm joining this, but I think from the diagram, the suction filter is not inclusive in it. I don't know if I'm right, but then I just want to give a try to it.
All right, thank you. As we progress, we'll be able to
Don't lose your breath.
in that line diagram. Please, you can try and meet your.
Listen to the like. Which brand?
That's over here.
IDEXPO, mute your mic. IDEXPO, mute your mic.
All right, thank you. The air conditioning in bracket AC system overview. This is the overview of the air conditioning system. An air conditioning system cools and dehumidify indoor and transfer heat from inside space to the outside through refrigeration cycle. This process uses a refrigerant which continuously circulates and changes between liquid and gas state as it moves through the system main components. And these are the components. We have here the compressor, we have condenser coil, we have expansion valve, we have evaporator coil, we have fan in bracket blower up or condenser fan. We have thermostat. Together, this component maintain a comfort and indoor temperature to that humidify or that humidity level, ensuring efficiency cooling and their quality. So that takes us to the compressor. That's a picture of the compressor. On that diagram, on the picture, we have the industrial compressor and the residential, which is a small one that look like box. And sometimes, depending on the system, most of these compressors come in 3-phase. I'm talking about this small one that look like a box now, or some is single phase. And of course, if you know if it is single phase, if that compressor does not start, does not really mean that the issue is the compressor. In every single phase induction motor, we require a starting capacitor to start the motor. As we progress, we'll digress on that. So the compressor, the main function of compressor is to compress refrigerant. Replace your heart with the compressor, then you understand what I'm talking about. What does your heart does in your body is to pump blood to different part of your body that need blood, right? That's the same thing that happens in compressor. The compressor compresses refrigerant to a high pressure and high temperature, and then deliver it to your condenser. If you go through the note said that compressor is the heart of the refrigeration cycle. It draws low pressure vapor from the evaporator and compresses it into a high pressure, high temperature vapor. This enables the refrigerant to release heat in the condenser. Then compressor maintains refrigerant circulation and ensures the pressure difference between the high and low side. So that let us know that the system has two sides, which is the high side and the low side. And somebody asked question how to differentiate the high side and low side yesterday. So from the discharge side of your compressor to the inlet side of your thermostatic expansion valve is your high side. Then from the outlet side of your thermostatic expansion valve, this is not in the note. The reason why I say we should also try to jot down things. I don't know. If I'm too fast, please you let me know. So it is from the discharge side of your thermostatic expansion valve or TSV to the suction side of the compressor is your low side. You can also use the size of the pipe to differentiate this. The discharge side, the pipe is always very small or it's smaller, while the suction side, the pipe is always bigger. So you can use that to differentiate it. The discharge side is your high pressure side. The suction side is or the low side is your suction side, which is a liquid line, or sorry, the refrigerant line. So that takes us to the next item. After your compressor, what do you have from the line diagram? It was from the compressor to the oil separator. So now we have your oil separator. And what is the function of the oil separator in the system? Is to separate oil, right, from the compressed refrigerant. And that oil will go back to your sump, the compressor crankcase. So the oil separator removes oil carried by the compressed refrigerant vapor. It separates oil droplets from the discharge gas and return the oil to the compressor crankcase through a small return line, as you can see in that diagram. This prevents oil from circulating through the system, ensuring proper lubrication and extending compressor life. In your automobile, the system is not like this. You can travel with that oil. The reason why, if your AC system, I'm talking about automobile now, is leaking, it is recommended to rectify the leaks instead of going to top up refrigerant. Because not all the technicians out there will understand that when you are topping up, and if you have a leakage system that you're supposed to add up oil. Because where that refrigerant is leaking out from, oil is also leaking out from there. that oil is supposed to go back to lubricate your compressor. Not only lubricating, also stand as a cooling agent to that compressor. So if you go around topping refrigerant, you end up packing your system. That compressor will blacktate. That small compressor that you has 6 to 8 piston inside. So if it's running with what does that mean? That moving metal to metal. If you are not talking, mute your mic, or we'll lock you out from the class. If you are not talking, kindly please mute your mic. Thank you.
Zoe, please mute your mic. Zoe, mute
All
your mic.
return line.
Hey, Pastor, mute your mic.
This is your oil return line. A small oil return line carries a separated oil from the oil separator back to the compressor crankcase. This maintains proper lubrication without interrupting refrigerant flow. So the oil separator is just there to separate oil that's supposed to leave your crankcase and pass through the line. So this oil separator just return that oil back to your crankcase, and that takes us to your condenser. A condenser receives high pressure, high temperature vapor from the compressor. So what the system does is that the compressor compresses the refrigerant to a high pressure and high temperature, then deliver it to your condenser. Here the refrigerant release its heat to the surrounding air or water, condensing into a high pressure liquid. Air cooled condenser use a condenser fan to blow air across coil, while water cooled condenser uses a water pump to circulate the cooling water. This depends on the system. Some of the system, the condenser is it uses fan to expel the heat, while in some systems like industrial or vessel on they use this cheap cooler. So the seawater cools and then and go out. The diagram that I was asking you what is missing there was the condenser fan and the evaporator blower in that diagram. So where you have the condenser, you're supposed to attach fan there, and where you are a cooling pump depending on the system, and where you are having your evaporator, there was supposed to be a condenser evaporator fan there, which will help to expel the cool to to your cabin. So what simply means is that because the HVAC system they are working as a team, right? If any of the parts stop working, the whole of the system will not work. For example, if you are using a tip or a cooling condenser, if your seawater pump or GS pump got bad or is not running, or probably the where you're sucking the water from, maybe the strainer get choked and the cooling is not proper, it will not be able to change that refrigerant state from gaseous to liquid. Sorry, yes, from gaseous to liquid. Don't forget the compressor compresses refrigerant to a high pressure and deliver it to the condenser. The condenser is where it's supposed to cool it down and further help it to change the state from gaseous to liquid. Before going to your filter dryer and expansion valve. Don't forget what happened there. It only cools down the refrigerant, but the pressure is still there. As we progress, you know where the pressure drops. So that's that on the condenser. So the condenser fan or water pump, if you are not using fan, you use water pump. In air cool system, a condenser is using condenser fan to remove heat by blowing air over the condenser coil. In water cool system, a water pump circulates the water between the condenser and a cooling tower or heat exchanger. Both are essential for effective heat removal. So if this pump is not working or the condenser fan is not working, you will not be able to remove that heat. The heat will still be there, and that heat will return back to your compressor. If like that one in automobile, that compressor will overheat immediately and got damaged. So that take me to most especially those that when you purchase a car, you be brainwashed that you're supposed to remove thermostat. Thermostat is not for Nigeria and all those stuff. I don't think that is true, right? Your condenser fan in your automobile was not designed to work continuously. It was supposed to work when it's required, meaning it's supposed to work and stop. The reason why some of the people that alter their fan and put it in direct have issues with their condenser fan, have issues with overheating because that fan is running continuously. Let's assume that you are doing a transportation job. You run from Uyo to Lagos like every day. And as soon as you leave Uyo to Lagos, that fan will continue to run till you get to Lagos if you are using AC. And it was not designed to work like that. Apart from even AC, even your main cooling fan, by the time you remove the thermostat, the fan is being connected direct. So you are telling that fan to work continuously and you expect it to last. It can't last. The manufacturer did not do that or make the fan to be running continuously. It was supposed to work and stop. And that is being controlled by your thermostat. So that's that on the condenser fan. So that takes us to the filter dryer because after your condenser, you have what? You have your filter dryer. Your filter dryer is supposed to be there in the system to trap moisture and metal shaving. Those are moving. The compressor is a moving part. There's a possibility of wear. So your filter dryer is supposed to collect that, right? If you have ever purchased a shoe before or an electronic, you see something like a sachet inside that electronic. That is called silica gel. If you open, you see small seed inside. It's called silica gel. What that does in that package is to fight against moisture. If that thing is not, the moisture will attack that electronic. For example, let's use your shoe for example. You're on board or you have left your compound or your house for a long time and leave your shoe. When you come back, what happened? You see moisture over the shoe. If you try to clean it, most time that shoe might peel. But if you have silica gel or if you have this thing, this silica gel there, moisture will not go near that shoe or any of that electronic. The same thing happens to the system. But we have the silica gel which fight against moisture in the system. That's the reason why it's always advised anytime the system is open for repairs, for maintenance, for part change, you need to vacuum that system to 28 to 29 inch of mercury before recharging it with the system. Why? Because refrigerant and air does not mix. If it mixes, it causes acidic corrosion. So the filter dryer remove moisture and contaminants from the liquid refrigerant. Moisture can freeze and block the expansion valve, which may damage the compressor or valves. It ensures clean, dry refrigerant for smooth operation. So that's the work of the filter dryer. Fight against moisture and metal shaving in the system. It's also a safety device to your expansion valve because that expansion valve is the holes there are very tiny. So if you don't have filter dryer there, so every metal shaving or in the system will get stuck in your expansion valve. And it's also recommended that every 2 years the filter dryer should be changed. Or anytime the system is open for repairs or maintenance or part change, the filter dryer should be replaced. But most time we don't really follow that because the system is working. But that's not the recommendation. So you also have a solenoid valve. Solenoid valve act as an automatic off/on control for refrigerant flow. It's open when cooling is required,
I hear you now.
and closes when the system is off. This prevents refrigerant migration when the compressor is stopped and is usually controlled by thermostat or pressure switch. And this is your thermostat or your expansion valve, TSV. In some system, it's capillary tube. They are all doing the same function. The expansion valve regulates refrigerant flow into evaporator. It reduces pressure and temperature, allow the refrigerant to evaporate and absorb heat. It works with a sensing bulb to maintain constant superheats and prevent liquid refrigerant from returning to your compressor. So this simply means that the work of the expansion valve is to cause pressure drop and further regulate the amount of liquid refrigerant that's supposed to go into your evaporator. Remember, the compressor compresses refrigerant to a high pressure and high temperature. In that temperature side, the condenser have already been taken care of that by cooling the refrigerant down and help it to change its state from gaseous to liquid. And the pressure is still there. So when you get to your expansion valve, the pressure will drop. So that is the work of the expansion valve, to cause pressure drop and further regulate the amount of liquid refrigerant that will go into your evaporator. And this is a sensing bulb. The sensing bulb is part of the thermostatic expansion valve assembly. It senses the temperature of the evaporator outlet and adjusts the valve opening accordingly. This ensures proper superheats and efficient evaporation of the refrigerant. Like in vehicle, you need, when you get a vehicle, sometimes when they bring that sensing bulb, if it got bad, they will now put external thermostat for you. I know most of us might have had that experience. They will put an external thermostat for you, and if you can see, that external thermostat is always secure to the return line, that one that is cool, return line in that your system. So this sensing the temperature of the evaporator and allow the expansion valve to regulate the liquid refrigerant that will go into your evaporator. And here is your evaporator. Evaporator is where it's going to lose that coolness to the interior of the car, to the interior of your cabin, and further change its state from liquid to gaseous. And of course, the evaporator also cannot achieve that alone, right? You need evaporator blower. So if that your blower fails, it's not running, what will happen to the system? It will ice up and it will return liquid back to your compressor, which your compressor was not designed to compress liquid. Somebody asked a question yesterday, which we did not answer it. It was talking about this ice up. Because what really happened is that when people notice ice in the pipe, they just assume it's refrigerant. You need to top up refrigerant. But that's not true. If you should be able to identify the high side and the low side pipe, and also understand that the system where you should be able to know when, even without using your manifold gauge, to check when you need to top up refrigerant or when you need to check for leaks, right? So if the high side pipe, which is a smaller one, eyes up, that is low on refrigerants. If the pickup side, which is the suction side, the pickup pipe, if that one eyes up, does not mean the system need refrigerant. It could either be that the evaporator fan is not working. For those that are using motor with belts, it could be that the motor might be running, but the belt connect between the fan and the motor might have caught. So your fan is not rotating to expel that coolness to the cabin, to expel that coolness to the interior of your house. So what happens is that the evaporator will ice up. Before you see that ice in the line going back to the compressor, know that the evaporator is safe, it's fully full with ice, right? It could be that your suction filter, that is evaporator filter, is being choked up. It could be that the evaporator is safe, it's being choked up, because sometimes people use high pressure water to flush the evaporator. So if you flush it, what happens? You close the fin. So even when the fan is working, you will not be able to pass air across the coil. So that will make that your unit to ice up. So not every ice up means that the system is low on refrigerant. You need to check and find out what is the issue. At this point that I'm talking, we are also doing the troubleshooting at the same time. So evaporator is where the actual cooling occurs. The low pressure liquid refrigerant absorb heat from the surrounding air or produce or product evaporating into vapor. This process cool the air before the vapor return to the compressor to repeat the cycle, right? So at this point, the liquid refrigerant will change the state from where? From liquid to gaseous before going back to your compressor, because liquid is incompressible. Your compressor was not designed to compress liquid. And at your condenser, what happened? So we have two places that the refrigerant in the system changing their phase. One change from liquid to gaseous, and the other one change from gaseous to liquid, right? From gaseous to liquid is at your condenser unit. Then from liquid to gaseous is at your evaporator unit. Take note of this because it might be asked during the tests. So this is the evaporator blower, right? The evaporator blower circulate warm air from the conditioned space across the evaporator coil. As the air passes through, it loses heat to the refrigerant and becomes cooler before being distributed back into the space. It ensures uniform cooling and good air circulation. That's just the work of the evaporator blower. It helps to expel the cold by sucking the air. It could be from outside, depending on the design. It could be from inside, suck it and take it over across the coil and then cool your cabin, and also help the liquid refrigerant to further change the state from gaseous or from liquid to gaseous before going back to your compressor, because your compressor was not designed to compress liquid. And also, of course, we all know that liquid is incompressible. So this is the system operation summary. Compressor draw in vapor and compress its oil separator, remove what? Remove and return oil to the compressor. The condenser with fan or pump rejects heat and condenses vapor into liquid. Your filter dryer remove moisture and metal shaving from the liquid refrigerants. Solenoid control valve control refrigerant flow. Expansion valve or melting device or TSV regulate pressure and refrigerant entering the evaporator. It causes pressure drop and further regulate the amount of liquid refrigerant that will go into your evaporator. Evaporator in black with blower absorb heat to produce cooling. Sensing bulb control expansion valve operation. Oil return line return separated oil back to your compressor. So that's the end of the class on the parts identification and their function. I will recap on this before I give room for question. I repeat, I said that the system is a closed loop, right? And it has two sides, the high side and the low side. The high side is the discharge side. We start from your discharge side of compressor to the inlet side of your thermostatic expansion valve, while your low side from the outlet side of your thermostatic expansion valve back to the suction side of the compressor. So the compressor compresses refrigerant to a high pressure and high temperature, then deliver it to your condenser. Your condenser is where it's going to cool it down and further change the state from gaseous to liquid. And of course, the condenser cannot achieve that alone without the help of your condenser fan, depending on the system, without the help of your cooling pump. Then goes to your filter dryer. Filter dryer will then trap moisture and metal shaving before sending it to your expansion valve. The expansion valve is where it's going to cause pressure drop and further regulate the amount of liquid refrigerant that will go into your evaporator. Evaporator then reject the coolness with the help of your evaporator fan to the interior of your cabin or interior of your car and further change the state from liquid refrigerant to gaseous, because liquid is incompressible. Your compressor was not designed to compress liquid. So it's time for question and answer. So you have any question, if you have any contribution, please raise up your hand, give you the floor. You ask your question, or you can also contribute to the class. The floor is open, please.
Question, sir.
Sir.
Go
Question.
ahead, sir.
Question.
Sir.
Okay.
My question is about icing. Please kindly explain more on the icing of the system. Hello, sir. Can you read me?
Yes, I'm with you. All right. On the icing, I said it before. What happened is that you should be able to identify when you are saying icing, which side of it is icing up, because people do misunderstood this icing. As soon as they see ice, they will just feel that the system is low on refrigerant. It's not all icing means that the system is low on refrigerant. You should be able to understand. When you understand your system, you should be able to know what to do. For you to be able to solve problem, you should be able to understand that problem. If you don't understand it, you will not be able to solve it. You might end up compromising the system or end up choking the system with refrigerant because our mentality is already tuned up to, okay, when it is high, it means that the system is low on refrigerant. So you need to troubleshoot and check. Check number one, is it the high side that eyes up or the low side? If it is the low side, just know that the issue is from inside. It could be that your evaporator filter is choked up. So in that regard, your evaporator blower fan cannot suck air across that filter, then across the coil to send it to the cabin. It could be that your evaporator fin is being choked up. It could be that the evaporator fan is not working. If the one that are using electric motor, it could be that it's not working or the electric motor is not working. And of course, if you're using electric motor, it might not really mean that that motor is bad. There's a capacitor attached to that motor. That capacitor might be bad. And the only way for you to be able to check if that capacitor is bad is with your multimeter. Most time, it might swell up. Most time, you can see the terminal start leaking. But most time, it can still look new, but that system is bad. When it look new, you simply need your multimeter to check if the capacitor is still good or bad. That's if you know how to use the capacitor. Use that to check. So if your fan is not working, if your evaporator fin is being closed up, if your evaporator filter is being choked up, there's no how the fan or there's no how that system will be able to expel that coolness to the environment. Supposed to expel that coolness and further change the state from liquid to gaseous before going back to your compressor. So you need to check that. Then if it is the high side that is icing up, that simply means that it's less on refrigerant. And when it's less on refrigerant, that means that the system is open, meaning that you have leakage. We need to check where it's leaking out from. Most possibly place to start checking is where you have the joint together, where you normally recharge your refrigerant. It could be that the scraper valve, that valve that is inside there that is stopping the gas from not escaping, is a scraper valve and it has a seal. So most time when you pick your gauge, you need to check the condition of the mouth of that connecting hose. If there is a sand inside, when you use it to connect it, that sand might help pierce that seal in that your if spreader valve. So in that regard, when you remove, even when you remove disconnect the gauge, you still see leakage on that charging port. So that means that you need to replace that spreader valve. If you have leakage in the joint, that means you need to pump down the system or vacuum it out or recover it out and brace where it's leaking out from before you can recharge it with refrigerant. If not, so you keep on recharging the system with refrigerant if it is leaking. So I don't know if that answers your question.
Yes, sir. Yes, sir. Yes, sir.
Okay, I also have a question, sir. Good evening.
Good evening, sir.
Okay. Thank you so much, sir, for this lectures. I have a few questions that I just want to ask and also to help others who might not really know. So you talked about if a capacitor is defective. A lot of us here might not know how to go about that to know if the capacitor is defective. How do we ascertain that our capacitor is defective? And again, how can we also test our compressor if it has fault? How do we go about it using multimeter to test our compressor if it's defective? Those are the two questions I have for now, and I'll say ask for them. Thank you.
All right, thank you. Your question you're asking is related to the system that is using a single phase. Because in a three-phase compressor, you don't need capacitor to run the compressor if it is three-phase. But the indoor unit, the fan, is always single phase, so you use capacitor. So, like for example, the residential, both the indoor and outdoor, the system is single phase. So what does that mean? In every single phase induction motor, you need a starting capacitor. Your fan in the house is also using capacitor. So most time, if your fan in the house is not working, does not really mean that the fan is bad. It could be that your capacitor is bad. The reason why you see when the fan want to start, it sluggishly try to start. But if you use your hand to spin it, you are now acting as a capacitor to make it to run fast. Then in compressor, if the issue is capacitor, it will try to start, it will not start, it will be humping. And you can see drag currents. If you are in the house, you notice that when it's trying to start, it will drag currents because that capacitor is bad. You need that starting torque. You need something to boost it to start. So for you to be able to know if your capacitor is bad or good, we have the capacitor that we have a dual capacitor, we have a single capacitor. The dual mean in that capacitor will have three terminals. One will serve as your common, one serve as you see the right there F, the other one they will write either com or they will write H. That H mean hematic compressor, that is where your compressor is supposed to be connected to. The F mean fan. Is the way your fan is supposed to be connected to. That the common is the current that come into the system or to the capacitor. So if it's the capacitor is rated 50 UF, as UF mean microfarad, they say plus or minus 5%, right? Plus or minus 5%. You need to calculate and know what is the 5% of 50. What is the 5% of 50? The reason why I do not want to put the troubleshooting today because troubleshooting somehow is kind of wide. Who can let me know the 5% of 50?
0.5.
Eh? 5% of 50.
2.5.
The 5% of 50 is 2.5. So that simply means that 50 minus 2.5 and 50 plus 2.5. So what is 50 minus 2.5?
The 79.5.
47.5.
Sorry?
47.5.
47.5 for 50 minus 2.5, right?
Yes, yes.
75.5. So 70 what? 49 point
47.5.
47.
47.5.
1.5. Okay, now 50 plus 2.5.
52.5.
7.5. 57.5, right?
0.5.
2.5. 52.
52.5, sorry. 52.5. So this is the working range of that capacitor. And for you to be able to test this, you have to use your multimeter. You see some of the people on the roadside, they will use wire to spark and say the capacitor is working. I don't actually believe in that because you cannot you cannot factor out what is the figure. So if you calculate this, you should be able to know, okay, if the figure is below this range or above this range, that capacitor is bad. So you simply need to replace it. And for you to be able to know this, your multimeter to use and check it. Daniel, are you on board? Are you close to your multimeter?
I have to go and bring it, sir. Let me just give me, I'll leave a few minutes.
All right.
Few minutes, sir.
Then proceed to another question. And also, if you want to check if your compressor is bad, you can also all this. You need to use your multimeter. The reason why, for some of us that finished from academy, uh, like me, I was not really a fan of electrotech. Our lecturing was one thing. The man was very good. You know, we just need to pass and go. So our focus was really on the engine, but the engine here hardly breakdowns. And if you break downs, you have other engineers that you're supposed to share idea and fix it. But when it happens to other small things like that, you might be left alone, But these basic things are very important, and you never can tell when they will help you. We should be able to know how to at least have the basic knowledge of electrical, know how to use your multimeter to check continuity, know how to use it to check voltage, know how to use it to check resistance. Because for you to be able to know if your compressor is bad or good, you need to know how to use your multimeter to check resistance, right? And that you have to select the knob to ohms. So you really need to know all these small things. For you to be able to use your multimeter also to check if you are to check your capacitor, you need to know where the symbol of capacitor, because they will not write the full capacitor, they will write UF. You will see something like this. Can somebody see my book? Can you see my book?
No, sir.
Yeah?
We cannot see your book.
You can't see the
No.
book.
No, sir.
You can't see my exercise book.
Oh,
Nothing
oh,
No,
is
we
you can't
cannot
say, you
see.
can't say, you can't say.
yeah?
Can't see
You
you.
can see the
Okay, I want
exercise book, not the write-up.
yes,
Not
I
what
will
is
show you the
written on
right
it.
term. I want to show you the symbol of microfarad.
We can see the book, not what is written on it. We can't see what is written on
I just want to be sure you can see the book. I will write something on it.
Yes.
You can see either of this symbol in your multimeter. So this symbol simply stand for capacitor, which is a microfarad. That's the symbol for microfarad. So during calculation in class, the man used to remove mark if you don't put symbol. You might have the answer, but if you don't put the symbol, you will lose mark. So all the small thing matters because in your multimeter they will not write full. Say okay, you are going to select the knob to here to check your capacitor. So need to know all this all these small sign and their meanings. Let's see. Since Daniel is on board, let him bring his multimeter. Then we can announce. He will now select it to us. Let's see. So for you to also check on your compressor based on the question Daniel asked, you need to select your multimeter to resistance and use that to check, and also check if the compressor is aiding to your it's short circuiting, as in it's aiding. So what you do is that from the three terminals, you use it to touch across it to check continuity. If the continuity, then that means the compressor is good. At that point of continuity, you should be able to also see your resistance reading. But if you check and either of the terminal does not beat, meaning that compressor is short. That's that on a Hvac compressor. So the floor is still open for question. So the question now is forming part of the troubleshooting.
Yes. Good evening, sir. I have a question too. My name is Daniel Okun Daniel.
All right.
Okay, sir. From your diagram, I want to ask a question from the diagram. What is provided in this
Hello.
system to sense the temperature
Hello.
of the room?
Can I go ahead?
Hold on.
Sir, did you
Somebody is
get the
asking
question?
question. Hold on. Somebody is asking question. You better just hold on.
Can
Sir, did you get my question?
No, please repeat, Daniel.
Okay, I said, what is provided in this, from this diagram, what is provided in this system to regulate the room temperature, the temperature of the room, sorry.
This is a line diagram, and I might not really be able to capture everything, but I'm going to end this screen and put it in another diagram. So what is helping to sense the room temperature and tell the compressors to either cut in or cut out is thermostat. It's a thermostat, right? This is your thermostat sensing the room temperature. let's assume now you set your thermostat, your thermostat to let's say 70 degrees Fahrenheit, and the working while the compressor is working is 75 degrees Fahrenheit. So until that temperature come down and equalize, your compressor will not cut off, it continues running. So that simply means that everything inside that house, the temperature must be cooled to 70 degrees Fahrenheit. Then this thermostat will now send information to the compressor to cut off. And how does this work? The thermostat is controlled by a 24 volt. The reason why you're having transformer in your indoor unit, right? That transformer is a 24 volt transformer, which compressor is connected there. So the compressor will now send information. Sorry, the thermostat will now send information to your contactor. That contactor will close. When it closes, the contactor stand as a switch between your lights, between your bulb. Let's assume it is you now. You enter your house and you want to on the light. So you press your switch to on, and it will close the loop for your light to come on. And if you don't need the light again, what happens? Also off the switch to cut off the light. So that's what the compressor is doing, the thermostat is doing by sending information to your contactor. The contactor will now close the loop and tell the compressor to start. And when the room temperature is cool to the set temperature, you now also send information to the contactor to disengage. And when it is engaged, your compressor stop working. So what's sending information to your compressor or to the system to work is your thermostat.
Thank you very much, sir. I get it now. Thank you, sir.
Nibe, go ahead. You wanted to ask question, right? Let me share.
Okay, sir. Good evening, sir.
Good evening.
Okay, Chief. My question is it all compressors that have this oil separator, or some of them is it embedded inside? Because some compressor I will not see any oil separator there. Is it inside?
This mostly is in this industrial AC. That's where you
Yes.
have oil separator. For example, in your automobile, the oil move around with refrigerant, right? It goes back to lubricate and also to the compressor. But on this bigger units, like industrial, they have oil separator that will separate the oil, and then the oil will then go back to your crankcase. In smaller units, there's no oil separator.
Okay, thank you, sir. Clear.
Um,
So please, I have a question, sir.
Push ahead. Let's make it interactive.
Okay, sir. Sir, please, my own question is on it's not particularly AC, it's reefer compressor.
Mm.
Please, the reefer compressor on board here in my vessel, I'm a cadet, sir. So most times there's always eyes towards the discharge side of the reefer compressor. Too much ice, and sometimes it's going to stop cut off. Then after some time, sometimes we allow the ice to defrost. After defrosting, we'll now use something to just break the ice. After some time, if you put the reefer on, before it's going to pick up, you will hear some noise coming like a noise coming like something like problem. What's the problem towards that reefer compressor, and what are the possible problems or troubleshooting causes of the problem, please? I don't think I really don't really have too much idea about HVAC system, but I'm open towards learning. That's why I decided to join the class, sir.
All right. If you say that it's icing up at the discharge side, what is your discharge pressure and suction pressure? It could be that the system is less on refrigerant. And also you need to check around if you see traces of oil where you have your filter dryer, where you have joints. Check even in your because that reefer is also fitted with oil separator. Where you have those connectors, check if you see traces of oil. That means the system is leaking out slowly. Number one,
Okay.
the recommended suction and discharge pressure. Check there is a gauge there in that your river. There's a suction and discharge gauge. Check, are they in the recommended working range? Is it
I
low?
think most times the discharge pressure is I think 14. Then the suction is always the discharge is 14.0 bar. I can remember that.
So what is your suction? Is that the working pressure? Is that the recommended working pressure? Most especially in the
I'm
suction
going to
side.
make
So check if it is
okay.
less than that is what is most especially is icing up on the discharge side. Will be that it's less on refrigerant. Also check the lines where you have your filter dryer where they are connecting. There are knobs there. Check if it is wet and with it is oil that is there. You know that the refrigerant is leaking out slowly. And most time you might not be there. You see that maybe your chief engineer or second engineer will just go and recharge the system.
Yes, they always normally collect gas at the condenser side.
So the system has leakage somewhere. That's why.
Then the suction pressure is most times 2.0 bar.
That 2.0 bar, is that the requirement? Just check. I want you to check. Let it be like an assignment. Go and check. Is that the required working pressure of that river?
Okay, sir.
From there, you will know. Also, check the line. Check where I'm telling you.
Okay.
Everything is just there. Apart from the evaporator unit, that's your cool room or your chiller. Other things just there in one stand, right?
Yes.
So check.
Okay, sir. Thank you very much.
Please, the floor is still open for question and contribution. Okay, Charles, are you there?
Good evening, sir.
Good
Good
evening.
evening, sir.
Good evening.
Can I proceed, please? Hello.
Go ahead. We can hear you.
All right. My name is Kennedy. I'm happy to be here, and I thank you for your class so far. I want to ask, please, what are the common signs of a bad sensing board? We've been talking about it for a period of time, so I would like to know the common sign of a bad sensing board.
Yeah.
Did you get my question, please?
Yeah.
Hello?
Hello. Go ahead.
Yeah, I said, my name is Kennedy. I would like to know the
Yeah.
common sign of a bad sensing board.
I don't know where I'm to start from. Common sign of a bad sensing bulb because the sensing bulb is attached to your thermostatic expansion valve, which help to regulate the expansion valve is regulating the pressure based on the sensing bulb. Uh, though I've not really.
Because most times the bulb can actually be bad. I've noticed one on my vessel,
Hmm.
and I realized that it was having an improper superheat. Sometimes it regulates. And the liquid on the refrigerant started entering the compressor at some point. So we had to change that. And at the process of changing that, we mixed the lines. It was not really fitted. So we had to take off that particular one and fix another one. But I know that there are other common signs that should actually show, which I would like to know, or every other person would also like to know in here. So
No, I'm not sure.
I would like you to help us because
I'm not sure the bar sensing bulb will make liquid to return to the compressor. The only thing that will make liquid to return to the compressor, if we want to say practical wise and based on our lecture, don't forget the evaporator blower help to expel the coolness to the interior of your car or interior of your cabin, and further help the
yeah,
liquid refrigerant to change the state from liquid to gaseous. So anytime you have that flood back is probably if your evaporator blower is not working properly or is not even working at all, or your filter dryer is being or sorry, evaporator filter is being restricted. So the blower fan cannot expel or cannot suck in air to pass across the coil to help it expel the coolness and further change the state from liquid to gaseous. Because what the sensing bulb does, it just help the expansion valve to regulate. It's either to open more or closes, right? The sensing bulb help. Check the note.
yeah, from yes, from the sensing bulb, it ensures that no liquid refrigerant enters the compressor.
Mm.
That if it's not from the notes that I've read so far before now, that it can also cause a poor cooling performance. Yeah, in the cool stress.
Yeah, it will cause poor
Are you with me?
performance if you do not allow the expansion valve to open properly, giving wrong information. Can you hear me?
Yeah. I'm hearing you now. Hearing you.
Yes, I say it can also cause poor cooling performance because he is the one responsible to help the expansion valves to regulate that liquid refrigerant that goes into your evaporator.
Yeah.
But making it to flood or to return liquid back to the compressor is what I don't really understand practically. But I know it helps to regulate. It's either to tell the expansion valve to open more or to close. Just it help the expansion valve to regulate that liquid refrigerant to go into your evaporator.
All right. Thank you. Thank you.
I don't know if that makes sense.
Yeah. It's fine. Thank you.
All right.
Appreciate it.
Okay, any other question?
Hello, sir. Good evening, sir.
Good evening, sir.
Okay, please. My question is, you displayed two compressors, one for residential and the one for industrial. So for the one for residential, how do you if there's no space where you can see a leakage, like maybe like the floor or a base that displays the leakage of the oil, how do you know the oil is short? How do you identify a leakage? And how do you know the system is short of lubrication oil?
Just as I said before, anywhere you have leakage in the system, you will always see traces of oil um, uh, uh, down there, meaning like refrigerant is leaking out from there and also oil is also leaking out from there. So most especially in automobile one side, we have this oil measuring tool. Let me just use the opportunity to explain this. There's a chart that explains the percentage of oil that's supposed to go into your compressor, the percentage that's supposed to go into your evaporator, your condenser, probably the line. So the compressor always have the highest percentage. So you also recommend that anytime the system is you are replacing compressor, you need to push out the oil that is in the system, then and properly remeasure and distribute the appropriate oil to the compressor. This is really applicable to automobile side because the oil travel with the uh with the refrigerant. But in residential, that pneumatic compressor, the oil that is passed following that refrigerant to pass is very minute, you know. But where it's leaking out from, what will help you to see that is that you see that there's a little traces of oil there. So you might not really require to add oil. It's just for you to locate where it's leaking out from and rectify the leaks. And mostly, this leak always come from where you have two pipes joined together, where you have your filter dryer, even where in your it could be in your condensing coil or evaporator coil. Where you have your condenser or condensing coil, you see that those fins have been socketing as it's turning around the coil. So those particular spots, they brace them. The leakage might come from there. Same thing applicable to your condenser. It could be also the location of where your condenser is, impact of stone might make it cause damage. On the process of transporting it or during installation, it might be compressed and it start leaking from there. But there's no how, whenever you are having leakage, you always see a traces of oil there. And of course, we know that our refrigerant also contains some oil. So anytime it's leaking, you should be able to identify where it's leaking out from. So you see that you use your electronic leak detector, or you can use soapy, that is soapy water with foam, to check where you have joint to bubble. Another one can be during your vacuum. You can use your vacuum pump to check. But vacuum pump will not let you know the exact place that is leaking out from. And not all leakage manifests under vacuum. Some leakages manifest under when there's a pressure in the system. I don't know if that answers your question.
Okay, sir. Yes, it does. Thank you very much, sir.
So can I ask one last question, please? A quick one.
Yes, sir.
Okay, I can see your condenser has different colors. Can you quickly explain why it has different colors? Secondly, what temperature difference should call our attention? That is temperature difference between the seawater inlet and outlet of this condenser. A temperature difference that shows fouling or clogging with typical figures. Thank you.
Yeah, that's why you see, I want to believe if you are referring to this particular picture and also the one on board your vessel, you see that we have a suction and discharge pressure attached to your GS pump. I don't know if that is applicable to your own. And aside from that, at the inlet side of the condenser, there's also a gauge there. That gauge will let you know that probably where the condenser is being restricted. It could be the condenser is restricted. It could be that your strainer, because your GS pump is sucking that water, right? That passes through the strainer. It could be that your strainer is restricted. So for you to be able to know if it's your strainer or if it's your condenser, you need to compare these two pressures. What's the inlet pressure to your condenser? And what is the inlet and the suction pressure of your GS pump? From there, you should be able to know that your it's either your evaporator or your strainer is restricted. Then you clean it accordingly.
Sorry, sir, please, I'm talking about temperature difference in the inlet and outlet.
Let's leave the temperature difference aside. Let's assume, okay, I want us to be practical. Let's assume I don't have a gauge that shows the the inlet and outlet temperature, that which will help me to really know the water that is going out at the outer side. If you touch your pipe, you should feel that it is cool, or it is warm rather. Um, uh, because the inlet one is cool. So the one is going outside should be warm, meaning it has helped to extract the heat from the refrigerant, then send the heat outside. But if the pipe temperature equalize, let's mean the one that is coming in is cool and the one that is going out is cool. That simply means that your what do they call your condenser is restricted and it needs to be clean.
All right, thank you, sir. That is clear. Thank you. Please, about the color, can you explain these colors on this your condenser?
Yeah, the color here, the one that is green is the cold, and the one that is hot is that is red is the hot. If you can see the arrow shows it's going out, you see the arrow that the green means that that's the water coming in, and the hot side going out.
Okay, that is clear. Thank you. I did not notice the arrow.
Yeah.
All right. So if you have any question, you can just drop it at the chat box. We're already our time is fast spent. I needed to make some clarification to you guys so you understand how far we've gone and been on the educational support service and how do you validate your certificate or why is certificate important? So from my side, please, I hope everyone is listening.
Yes, we can hear you, sir.
Okay.
Yes, sir. Please go ahead.
So I will just quickly run down to you what is CPD and why is it important. So CPD refers to continuous professional development. It's for learning, training, and skill development. Yeah. So it's to make you stay up to date. It's not a educational qualification, but it's for your continuous improvement during your career, work on board or in the office or anywhere you find yourself. It's your continuous improvement while you are on the job, so that you don't forget something, so that you get abreast with new technology. Hello.
Hi, sir. Please go ahead. Very good.
So it's important that we keep to our standards. That is why we would have said, okay, we can just bypass and send your records for certificate, but no. So before the end of the week, you get your assessment via your emails, and immediately you get it. Remember, it's just 48 hours to submit. So only those that submit will be able to forward. And if you want to submit it, please submit it in PDF format. The PDF format should carry your name as the file name. Then on inside the PDF format, you write your name, your email, your phone number, and your nationality. Well, we're all Nigerians, but then you have to just put nationality there so that then you answer all the questions in Word format before converting it to PDF and send the file. Note that after they receive, they will now forward it for final assessment. For you to confirm your CPD, on your certificate, there will be a number. There will be a number. The most important thing is that you confirm that the issuing authority is actually CPD compliant. So you see the name of our company as CPD compliant. So you can as well, if you want to put that certificate in your CV, you can put it as professional development certificates.
Yes, mommy.
Am I clear?
Yes, mommy.
Professional development certificate, clear, sir.
Yes.
Yes, sir. Yes,
Yes,
sir.
We're
Loud
going
and
to
clear,
have,
sir.
yeah, so we're going to have more of them. For those of you that have been with me for some time, I believe that some of you have some other certificates already that were done. So you can put those ones under your professional development so that even your employer or whoever is going to employ you will see that, oh, this person is learning even on the job. Not that you're just working and then you're not improving yourself. So that is why it's important to have your CPD records, okay?
yes, yes.
Okay.
Thank you very much.
So for I think almost all of you are still in the crane. The only challenge I have is that honestly, I don't have time to compile, and the person that was supposed to take the crane lectures has been so busy and this is something that has to do with a free lecture, so we have to follow their own schedules, not our own schedules. So apologies for that, but for this one that is ready, I believe that you have gained one knowledge or the other. So all we need for you is to inform others, because our goal is to have at least 2,000 certificates before the end of 2026. So all your certificates will be ready on the first week of January, hopefully, so that it will count in 2026. So thank you very much. Your certificate might come in one file. All you need to do is for you to check your own certificate in the file and download yours. So other than that, I think that is all for now. And I wish you guys, is it Merry Christmas now or what? Okay. Merry Christmas and Happy New Year. If we don't have, I don't think we're going to have a session, but then we might have a session before New Year. So
Same to you, sir.
Same to you, sir. Thanks to you and thanks to Engineer Ivo. Thanks to everyone as well.
Okay.
Merry Christmas, Engineer
Thank you and God
Charles
bless.
and Engineer.
Thank you.
I
Thank you so
second
much.
that wish in Jesus' name. Yeah.
Okay, thank you very much, guys, and I appreciate you for joining. So
Somebody take a screenshot
we
for us.
will. If you have, sorry.
A screenshot. You can do a screenshot, and also, please, if you have any question or concern, don't hesitate. So it might not really wait. Don't always wait until we have class.
Right.
Just to us.
Who is not around today? Who will be able to take the screenshot? Just turn on your videos and then we take the screenshot. Yeah. Who is using a laptop that can take the screenshot?
Please, I will need. How can we get material for this lecture today?
You want to pay for it?
No. Maybe in a soft copy now.
Soft copy, they know they pay.
Oil and gas.
Yeah.
In some places now, after they hold this now, they will say, okay, let's send something to our trainer, Engineer Ebong, send your account number. That's what it's supposed to be, but all of you will just be saying thank you.
So with time,
Which
we'll run
with
down the
time?
dollars. With time, we'll
Okay,
run down
no
the
wahala.
USD.
Thank you very much, Engineer Ebong. Please, someone should take the screenshot, and then that will be all for now. Thank you very much.
Thank you, sir.
Good evening, all.
Hello.
Okay.
Hello,
I
sir, can you
think
hear me?
Screenshot is done.
So can you hear me? Can you hear me, please? Hello?
Yeah.
Please, sir,
Hello?
kindly confirm screenshot is over.
Engineer Charles, can you hear me?
Yes.
All right, sir, I don't know, if it's deemed fit from your side. There are some persons that would have loved to join the class, and probably they're at work or maybe on their busy schedule. So I think it will be nice from my own end if anyone can just put a summary of everything that has been taught today on the platform, so they can just learn from it. Although they didn't attend the class today, you can just pick one or two things from it. At least it's going to motivate some persons next time to also join as well. Yeah. Thank you.
I thought you have done the summary yourself so that you can help us share.
Okay, yeah, I did my own summary, but I think from the lecturer it will be best fit he just drop what he can from his own side as well. Yeah. So it
Okay,
will
no
be
problem.
a bit powerful.
That
Yeah.
will be taken care of.
All right. So thank you.
All right, thank you very much, and you have a wonderful evening.
Thank
All
you,
right,
sir.
so I'm
Thank
just
you, sir. Bye
Really
for now.
appreciate.
Permission.
Okay, bye.
Thank you. Bye.